Good morning, my YouTube viewers. In this video, what we're going to do is we're going to conduct a hypothesis test using the t-distribution. And so we're just going to go over the 4 ways that you perform a hypothesis test. Number 1 is you state the hypothesis. Number 2 is you formulate an analysis plan. And number 3 is you analyze the sample data. And number 4 is you interpret the results. So we're going to perform a question on hypothesis test using the t-distribution. And if you remember my previous videos, a t-distribution is similar to a normal distribution with the exception that it has heavier tails. So a researcher is comparing the effectiveness of 2 teaching methods in small classes would use a t-test to determine whether the observed difference in mean test scores is significant. So we've got teaching method A and teaching method B, and you have about 20 samples for teaching method A and teaching method B. So teaching method A is a random number between 60 and 100 for 20 rows. And a random teaching method B is a random number between 50 and 100 for the 20 samples. So the thing that you're going to keep in mind is teaching method A has different scores from teaching method B. And the way we're going to do that in this particular example is we're going to use the data analysis toolpack in Excel. So you come over here to data, you come over here to data analysis, and we're going to perform a t-test. So we're going to go down here where it says t-test, and we're going to use 2 sample assuming unequal variances. So we're going to assume unequal variances, and so we're going to click on to OK. And then you're going to give you the range for 1 is going to be A7, A26. Range for B is B7, B26. And then what we could do is we're going to make it A6, and then B6. And then the reason why is because we're going to click on labels, and we're going to say an output range. And in this instance, we had an output range in D, D1 or D2. And then you would click OK. And then what that would do is that would automatically calculate that for you. And so we're just going to say that we clicked OK on all of that, and it automatically calculated a t-test for 2 samples assuming unequal variances. And then so we've got our mean for number 1 is 81.95, and for method B is 77.05. We've got our variance is 136 for method A and 223 for method B. So you can see method B has a higher variance than method A. You've got 20 observations for method A and B. You've got a degree of freedom of 36. And you've got your t statistic is 1.154. You've got your p-value is 0.12 for the one tail, and you've got a t-critical is 1.68, p-value for 2 tails is 0.25, and a t-critical 2 value is 2. You've got your alpha of 0.05. Your null hypothesis is there is no significance difference between the 2 teaching methods, and your alternate hypothesis is there is a significance difference between the 2 teaching methods. So we're going to interpret that. You're going to say if E17 is less than E20, then you're going to reject the null hypothesis. Otherwise, you're going to fail to reject the null hypothesis. So we've got E17 as being 0.25 and 20 as being 0.05. So you're going to fail to reject the null hypothesis. So they're saying that when you fail to reject the null hypothesis, what you're saying is that there's no significant difference between the means. So you've got the mean A is average of A7 to A26, and the mean B is average of B7 to B26. And then what we do is I've created a chart for you so you can see mean A is 79.25 and mean B is 78.3. So that concludes this video. The next video we're going to be talking about a hypothesis test with a chi-square test. So I hope you decide to watch it.